In this section, we are going to discuss vector database, also called as vector store, with practical implementation. A vector store is a tool that helps us store text in a smart way so we can find similar text later. This is very useful when we want to search by meaning, not just by keywords. The whole process starts by taking our data and breaking it into small pieces. Now let's understand the full process. So we are going to discuss vector store in a very simple way. So let's get started. First, we take our documents and break them into small chunks. A chunk can be many things. A whole paragraph can be a chunk. One full page can be a chunk, or even a small group of characters like 200, 300 characters can be a chunk. It depends on how we want to process the data. Next, we need to convert these chunks into numbers. For this, we use something called an embedding model. An embedding model takes text, turns it into a long list of numbers. These numbers are called embeddings, and they represent the meaning of the text. So similar text gets similar embeddings, and different text gets very different embeddings. After we get the embedding for each chunk, we store both things inside the vector store. So vector store contains two things: the chunk of text and its embedding, its numerical representation, right? The vector store also creates an internal index, so it knows which embeddings are closer to each other. Later, when a user asks a question, we again use the same embedding model. We convert the question into an embedding and send it to the vector store. The vector store compares it with all the stored embeddings and finds the closest matches. Then it returns the chunks of text to the user that best match with the user's question, not the embeddings. I repeat, it returns the chunks of text that best match with the user's question, not the embeddings, because embeddings are only used internally to find the matching text. Some common vector databases you will see today includes Chroma, an open source vector store used a lot with Langchain. Next, Faiss, F-A-I-S-S, created by Facebook, Meta, very fast and used for local setups. Next, Pinecone, a popular cloud vector database. Next, LensDB, a simple and efficient local vector store. Here in this video, we are going to use Chroma and Faiss with Langchain. So these are the most common vector stores used in real projects: Chroma, Faiss by Facebook Meta, Pinecone, and LensDB. So the full process is very simple. First, we break the document into chunks, create embeddings, store them in the vector store. Then take the user's query, convert it into an embedding. Then we are storing embeddings of the query also in the vector store. Then we are finding similar chunks and return those chunks of text to the user that best match with the user's question. As simple as that. So this is the basic idea behind the vector stores or vector database. This is the same idea used in RAG systems that we are going to discuss next. So now let's start writing the code. So what we are going to build? We are going to build a simple resume parser using embeddings and a vector store. So let's create one new file, resume parser.py. So you can see for this project, I have created this text file, resume.txt. This file contains 5 simple text-based resume that you can see, each one with a name, role, skills, experience, and education, covering profiles like Python developer, data analyst, etc. that you can see, right? You can take this from my GitHub account. Link is provided in the description of this video. So this is the simple text file that we are going to use. So we need a few imports from Langchain _community document _loaders. Let's import text loader. This is used to load our resume.txt file. Next, from Langchain _text _splitters, let's import recursive character text splitter. This will help us to break the resume into small chunks. Next, from Langchain _OpenAI, let's import OpenAI embeddings class. This class will help us to convert text into numerical vectors into embeddings. Now the main import from Langchain _Chroma, let's import Chroma. This is our vector database where we will store the chunks and their corresponding embeddings. Also, we have to import from .env, we have to import load underscore .env and load underscore .env. These loads all environment variables including the Open API key. Now let's load the resume file. This one we have to use text loader, and here we have to pass our file resume.txt, and let's assign it to one variable loader. Next, loader dot load. Let's assign it to one variable docs. This reads the entire resume.txt file into memory, right? This file that I just showed you. Next, let's split the resume text into small chunks. So for that, we have to use recursive character text splitter, and let's use chunk size is equal to 200 characters and chunk underscore overlap is equal to 10. Let's assign it into one variable splitter, and splitter dot split documents, and here we have to pass this docs, our text file that just we have loaded from here, right? And let's assign it to one variable chunks. As you can see here, chunk size we have selected is 200, means each chunk has around 200 characters, and chunk underscore overlap is equal to 10, means each chunk overlaps with the previous chunk by 10 characters. The second chunk will contain the last 10 characters of the first chunk. Same, the third chunk will contain the last 10 characters of the second chunk. Likewise, so this overlap helps the model understand the link between chunks and improves search accuracy, right? Now let's move on and let's create the embedding model. So here we are going to use OpenAI embedding model, default one, and let's assign it to one variable emv. So this converts every chunk into a vector, a list of numbers. Now next, let's create the vector database or vector store. So here we are going to use chroma.from documents. Here we have to pass two things, chunks and this embedding model. Let's assign it to one variable db. So here chroma takes the chunks and their embeddings and stores them inside a local vector database. So now we have completed up to this. We break the document into chunks. After that, we create embeddings and store them in the vector store. Now the next step will come. We are going to take the user's query. Also, we will convert it into an embedding, and also we will store inside the vector store. After that, we find the similar chunks. After that, we return those chunks that best match the user's questions to the user, right? Let's do this. Now let's take a search query from the user. Let's use input and let's tell the user search for skill or role. Let's assign it to one variable query. Now we have to convert the user's query into an embedding, right? Using same embedding model, using embed underscore query. Let's pass the query and let's assign it to one variable query vector. Now let's perform the similarity search. For that, we have to use this db dot similarity underscore search underscore by underscore vector, and here we have to pass this query vector. Optionally, we can pass this k value. So this will compare the query vector with all stored vectors, find the closest matches, and return the top 5 most relevant resume chunks. Because here we have mentioned k is equal to 5. That's why it will return the top 5 most relevant resume chunks. This argument is optional. Finally, let's print the results. Let's assign it to results first. For r in results sprint uline dot page underscore content, and also to remove white spaces, let's use this strip. So here each r is a small piece of text from the resume that matches the skill or role the user searched for, and that we are printing. Each are closest match with the user query, right? I think done. Open new terminal, clear this, and let's try to run this. This is our file name, right? Resume underscore parser.py, Python developer. Great. You can see these are the best match found by our vector store or vector database that you can see 2, 3, and 4, because they have mentioned something, right, which are related to Python developer. That's why it is printing this all resume, right? Hope all of you are clear with this, right? How to work with vector database or vector store. Let's summarize the entire flow. So here we have imported everything we need. Here we have loaded the resume.txt file. Here we are splitting the resume into chunks with a small overlap. Here we have created an instance of embedding model to create embeddings for each chunk. After that, we are storing everything in the Chroma vector database. Here we are getting a search query from the user. We have also converted that query into embedding and stored inside vector database and searched the vector store for the best match, printing the best matching resume chunks. Hope all of you are clear with how to work with vector database or vector store. Now let's discuss very interesting thing. We are going to discuss retrieval concept here. You can see until now we were taking the user's query and creating an embedding for it and then running a similarity search on the vector database. Now we are going to make this simpler by using a retriever. A retriever is like a helper built on the top of the vector store. You just give it the text you want to search and it automatically performs everything. Like it converts the query into an embedding, searches the vector database, and gives the back resume chunks that match your user query. So let's create a new file first with name retrieval.py, and we are going to use same code that we have created for resume parser. Implement the retriever right after this line. We have to use db.as_retriever. Let's assign it to one variable retriever. Done. So this is the first thing that we have to do. This line creates a retriever object from our Chroma vector store. From this point onward, we don't need to manually embed the user's query or call the similarity search function. The retrieval will take care of both steps automatically. Earlier, we were doing everything manually like this that you can see, right? So now let's comment these lines. Now we don't need these lines anymore because the retriever simplifies everything. Instead of these two lines, we will use the retriever. So after taking this user's query, we have to just use our retriever, this one, and we have to use invoke, and in that we have to pass user query. That's all. Let's assign it to results. Done. As simple as that, right? You can see after creating the vector database, we just add two simple lines. This initialize retriever and then we call this invoke method. As simple as that, right? Now the retriever does everything for us into one go, making the code much cleaner and easier that you can see. It is just two lines. And you can see this making our code much cleaner and easier, right? Hope all of you are clear with how to implement vector store with this manual step and with retriever, right? Now let's move on. Now let's run our code, Python and retrieval.py. Now let's search for machine learning. Great. You can see it is running exactly the same, but now retriever simplifies everything. Our code looks simpler and cleaner that you can see, right? This way we can use the concept of retriever that you can see by just adding these two lines. Let's move on. Now we are going to discuss how to switch between vector stores. So we will switch from the vector store from Chroma to Fires. Fires by Facebook Meta, and which is a very fast. It's a great when you want a lightweight in-memory index on your machine. For that, let's move to our terminal. Let's clear this, and we have to install Fires CPU. The GPU package only if you have GPU support, right? So here we have to change to GPU, but currently we are using CPU. Let's press enter. You have to wait. It will take some time for the installation. Done. Let's clear this. Now I'm changing the same code. So in place of this vector store from Langchain _ community vector stores, we have to import Fires. This is the first line. Then in place of this, we have to use Fires. That's all. Done. That's the key change. Fires builds the index from the same chunks and embeddings. No need to change anything thanks to Langchain. It makes our switching from vector stores extremely simple, right? We just change this import and this particular line where we create the database. The retrieval along with the rest of our code stays exactly the same, right? Let's run it once. This time Python developer. You can see great output, right? I hope all of you are clear with how to use vector store means vector database, right? So we have used normal method also with retriever, right? Also we discussed how to switch between vector stores. So as we can see, Langchain makes switching very easy. Just like we can easily move from one vector database to another, we can also switch between different embedding models without any trouble. So now if we want to switch from the OpenAI embedding model to the Ollama embedding model, just we change the import and replace the embedding model line. That's all. Let me show this. So in place of Langchain underscore OpenAI, we have to import Langchain underscore Ollama. And from there, we have to import Ollama embeddings. Let's copy this and let's paste it over here. And we have to define model parameter. Let's use this. Let's move to CMD, Ollama and Ollama list. So I have installed this many models. Let's copy this. We are going to use Llama 3.2. 3 billion. Let's paste it over here. It is multi-model. It can generate text and it can generate embeddings as well. Let's save our file. Done. You can see we simply import this class Ollama embeddings and set our embedding model to Llama 3.23 billion. That's all. The rest of the code remains exactly the same. Let's try to execute this code. So user query is something like this. Python developer create exactly the same output. But now we are using embedding model from Ollama, Llama 3.2, 3 billion model. Now let's move on. Now suppose we want to move from Ollama to Google Gemini. So we have to follow the same process. First from Langchain underscore Google underscore GenAI, we have to import Google Generative AI embeddings class. Let's copy this and we have to paste it over here and we have to change this model and let's use this model Gemini -embedding -001 that we are using since long. Done. That's all. Here we simply import this class Google Generative AI embeddings and set our embedding model to this and the rest of the code remains exactly the same that you can see. Save our code. Let's open terminal. Let's clear this and let's try to execute our code. Now we are looking for machine learning engineer. Great. You can see nice output. I hope all of you are clear with how to implement vector store. Also how to use retrieval that makes our code clean and simple. I'm sure also you understand how to switch between vector stores and how to switch between embedding models. Next, we are going to discuss